Assalamu alaikum. I am Suhaib Ahmed, working as a design engineer for Universal Engineering Services since past 7 years. Today, I am going to show you one of our projects which was designed and executed with the help of Autodesk Revit. So, we designed, constructed and commissioned this National Institute of Virology at University of Karachi in 2019, and since then we have been operating and maintaining this facility. Since the start of the project conceptual phase, we have been using Autodesk Revit to help us in the project designing. Okay, so now let's start with the civil layout. The civil layout was initially developed and then modified as per the requirements of the doctors. And while making this model, we ensured that all the properties of the architectural elements such as wall, columns, building windows, everything was modified and was as per the actual data that was received from the client. Now, after the completion of the civil layout, we started working with the equipment layout. The equipment layout was developed after a thorough discussion with the team of doctors. For the equipment layout, we had to develop the custom biomedical families which are usually not available with the manufacturers. So let me just show you the 3D model of the families which we have developed so far. Okay, so all the biomedical families are as per the dimensions that was provided to us by the client, and similarly the families also include the utility requirements such as the power requirement and airflow requirements if it is needed by the equipment. So after completing the biomedical layout, making all the custom made families, we proceeded towards the MEP designing of this facility. So let's start with the electrical layout. Uh, the placement of electrical fixtures was done as per the equipment layout, keeping in view the equipment power requirements. The electrical fixtures were then placed in the circuit and connected to the relevant panels. After completing the equipment layout, we started working with the MEP designing of the facility. So let's start with the electrical systems. We place the electrical fixtures as per the equipment layout and the specific equipment power requirements. After completing the relevant circuit designing, let's show you the list of power panel schedules. As you can see, all these power panels are electrically balanced on each face. Similarly, uh, the lighting designing of the facility was done with the help of the software. We calculated the individual lux level of each room and then placed the lighting fixtures. Similarly, the placement of lighting switches was done as per the required personnel flow. Okay, now moving on to the HVAC designing of the facility, the heat load calculations of the lab areas were performed and ducting work was started. Duct designing was done with the help of the software. We have made custom duct schedules which enable us to calculate the duct noise level. Let me show you the. So here is a schedule which where we have incorporated custom formulas to also enable us to calculate the duct sound velocity and minimize the duct sound, especially in the lab areas. As you can see, apart from the ducting and the relevant insulation details, we have also incorporated the duct hangers such as struts, angle irons, This will help us in the in better clash detection and better execution process. After the completion of area ducting, all the relevant air handling units were placed in the utility room. The air handling units in the model are based on the actual specification and the data that was given to us by the vendors. So all the sizes, the refrigerant connections, the duct connections, everything is as per the actual data received from the vendor, and all of this data is also incorporated in the model through type properties. The refrigerant piping designing and its support structure was designed with the help of this software, including the piping support network, which is also incorporated in our model. Let me quickly show you a 3D of our piping network. Here is a complete 3D view of the piping support structure as well as the cable tray that is running in the utility room. Now, apart from the HVAC and electrical works, we also designed the plumbing of this facility in the same model. Let me show you the plumbing. This is the plumbing layout of the entire facility, showing the supply and drain connections and piping for different laboratory areas. For our BSL-3 facility, there was a separate uh, drain system which was directly connected to the fill tank system. After the modeling process, we use inbuilt Revit scheduling feature to help us generate accurate BOQs for cost estimation purposes. So this is, for example, the quantity of non-SS ducts which is used in the facility. Now this is the quantity of SS304 ducts which was used in the facility. Similarly, the quantity of electrical fixtures used in the facility, the quantity of the air terminal schedules which are in the facility, the piping schedule used in the facility, and similarly the different types and quantities of lighting fixtures which are used in the facility. We are also using the inbuilt drafting feature of the Revit to help us with the generation of wiring diagrams for our BMS systems and developing system schematics. So here is an example of the wiring diagram of the BSL-3 controller, which maintains the negative pressure inside the BSL-3 labs and also controls the relevant HVAC units. Similarly, here's the air flow schematic diagrams which we generate with in the inbuilt drafting view of this software. Here is a schematic view of the kill tank system which is used for liquid waste decontamination. Similarly, we use Autodesk Cloud to generate 360-degree photorealistic renders of our projects. So here is the photorealistic render of the main lab area of this facility. You can see that all the equipment have the required texture and the lighting lux level, everything is as per actual provided value.